Welcome back to Chem with Kess, where today we're discussing ring expansions. To save a little bit of time, we should know the full-blown mechanism by now of the attack of the normal portion of the mechanism. So I drew the answers for you. It is really important, again, to understand why these answers are occurring. Right where the double bond is, that is where we are focused on and how we get our answers. So the left answer, I put the Br on the left carbon of the double bond and the other one the right. Now also, when it comes to drawing the intermediates for your carbocation are going to be in the exact same spot that your Br is in. So, oops, so positive charge right there. So now, these are the intermediates we're most likely using for our 1,2 ring expansion. Okay, so just a few little tips that may help you. A ring expansion technically normally has like a ring already involved in the picture, and the double bond tends to be on the outside of the ring because that is how we're going to expand the ring. Normally, ring expansions only expand by one carbon, but depending on the stability that we're looking for in a ring, it can extend to 2 carbons. Of course, you know I'm going to show you both of them. So the fact that I have a 4-membered ring, I should think that this will become a 5-membered ring. Now, when we discuss, or you go back to the video for chair conformations or cycloalkanes, as the ring gets bigger from a 3-membered to a 4-membered to a 5-membered to even a 6, it becomes more stable along the process. So since we have a 4-membered ring, turning it into a 5-membered ring makes it more stable. Can I turn this 4-membered ring into a 6 in this particular problem? Yes. But again, we have to go through the process of showing you how that is done. So first, here's our structure. Let's start with the carbocation that is here. And again, we still have like the Br minus that is present, and then I'll bring that one at the end. So what I like to do is, one, count my ring structure starting right next to where the carbocation is. I would start right here. If you want to number clockwise or counterclockwise, that is literally up to you. So this is how I would number it. You can number it the other way. And then where the carbocation would now be how my ring is going to expand to make a 5-membered ring. So the way I did that one, you should understand that if I wanted a 6-membered ring, I would be using the other carbocation, going through the same process of making this my 1, 2, 3, 4. This one would be 5, and the largest my ring could get would be 6. That would be where my carbocation goes. Now, again, I like to do things in color, so I'm going to put number 1 in purple and number 4 in red. The idea is the ring is expanding, so I am expecting for the side between 1 and 4, I need 4 and 5 to connect. So really, I'm going like this. So in order for the connection to occur, you would label these, you would label both of these as just 1, 2, RE, or depending on your instructor, spell out the word ring expansion. And then when the structure comes, you know that it will become a 5-membered ring for the top and a 6-membered ring. However, now we have to make sure we understand. Now, which one of these, the purple or the red? Am I really picking up to attach to the carbocation? So I like to tell students, if you pick up this one and move it over, essentially you are breaking a bond right here in order to do that. So really imagine me holding a pin at the purple and just picking it up to move it over to where the positive charge is. So between the two colors, really, number one is always going to be, if you draw it this way, the exact way that you would have your ring expansion go. Now, if you go through here and label everything, that's fine. So what I'm saying is, since number one is going to be the point of where everything changes, that is where your new carbocation would go, because the purple dot is what you're picking up to bring to the carbocation. Then after 5, you have other carbons. Sometimes I like to label them with letters so that way I don't mess up my flow. So that's A, B, C. Then I would have my Br minus complete the mechanism that we're used to, denoting that that is our fast step, and that would be our structure. Same idea for the one on the bottom. We know that at the end we want everything to connect together appropriately, so it's up to you how you number these things, in all honesty, but understanding this would go like this because that means 1 and 6 would connect, which should make a little bit of sense. It may look weird. Like, I absolutely understand that. This one's going to take a lot more practice. Feel free, if ever I'm running a huge group session, feel free to come in and ask all the questions you need, because things like this require a lot more problems and patience. So don't beat yourself up if you don't get it the first time. So again, number 6 has A and B sticking out. Number 1 will always be the one that I'm using to the purple to pick up to add to the number 6. Then I would complete my mechanism, same fast step. And then I would have created my now 6-membered ring for this problem. Now, depending on your instructors, why did I show you both of them? Every so often, instructors may give you the option, in a sense, and I'll have to do some more practice problems with you, but what normally would happen is they would show you the original and actually show you the end product that they want you to get, and then you just needed to know what you use, which is just the HBr. That would be nice and simple to put in the middle. Now, depending on your instructor and how they teach it, they would have made it clear whether you can do either one of these styles, but I always think about, if there's a possibility for the ring to be the most stable that it could be, it should be the largest, which we would expect it to be this. But also remember that 1, 2 means directly next to each other, so I should just be moving 1, 2 away. Instead of this would be 1, 2, 3 away. So that would be the difference. So in this case, the answer choice that most instructors would want would be this one, because this is the true 1, 2 ring expansion, compared to this one is really more like a 1, 3 ring expansion, and they just don't have anything that is named like that in the book. Is it possible? Can you do it and expand it to a larger size? Absolutely. But just pay attention to what your instructor is requesting from you. Let me know if you have any questions. I'm here to help. Leave any comments or concerns about ring expansions below.